about your wheel.
Okay. Since the last time we've been recording, that was like 3 weeks ago, 2 weeks ago.
Like 3 weeks ago.
3 weeks ago, and since that time, I finalized the design of the wheel. You see, it's a black tread. Not more gradations and troughs, peaks. Consists of this inner layer, and then you a lot of saws cut and then glued into it. Then this inner sheath goes into it, and yeah, that's what it is. The final result is pretty flexible. You can
Make
flex.
sure to crack.
Yeah. But yeah, we'll do a testing of this on every row as well.
Yeah, let's see how it does on like actual ground, because I'm worried about the paper's gonna like get like wet and it's gonna start like breaking apart.
Oh sure. The moisture you have to shake it, yeah.
I mean, if anything, we could just like take like a spray coat over it, like a clear coat, just to, like waterproof it.
Oh yeah. Yeah, that's about it.
Anyways, while he's been doing that, I've been assembling this. This is like the brain of the rover here, the brain in the body. So far I've got like 6 these micro stepper motors. My original plan was to use these so I can like determine how far I'm going, but these take a lot of power and I don't have enough energy for that right now.
You should speak normally because we are talking in a conversation.
I'm speaking to everybody.
Okay, continue. How about that? Can you like talk us through these bits of everything?
These little metal circles are the stepper motors. What these do is that they use magnets to spin this little bit around at a very precise angle. So I can spin like a couple degrees. I've got these micro servos just to turn the actual wheelbase so they can go side to side. And then this part right here, it's an Arduino knockoff. It's based on the Arduino Mega 2560. It's got a lot of ports for all the stuff I'm using. And then back here is just my power bank. That way I can power this. Over here, I took it off for now, it's just too many wires in the way, is the camera. It's a 2 megapixel or 1080p camera that we're going to be able to attach to here and take pictures of the rover. And this is a temperature humidity sensor that will also attach to here to give it some kind of scientific value.
We're going to talk about how this camera has been functioning as a dual ratio.
The camera's been functioning.
Oh, that's been functioning.
I just don't know how to work it properly.
It's not 1080p as in 2 megapixels. I mean, like for reference, the Curiosity, this is Vector Book. The Curiosity, the mesh cams are these 2 bits here. The mesh cams are 2 bits there, and each of those are 2 megapixels each, which is the same as this one. Like, the specs are the same, but
yeah, but this is like running off of these couple of wires, so it's like professional cameras.
So
this isn't gonna get nearly as good of an output.
Okay. We're gonna talk about how your power system is doing as well.
Yeah, I kind of mentioned it because each stepper motor requires at least 5 volts to function right. Right now I have the standard like phone battery power bank, and it does not give out quite enough batteries. And so like the lights turn on to say that it's receiving power, it's working, but the actual motor doesn't spin, and the ones that do spin I could put my finger on and it stops it because it's no torque. So I'm either gonna get like some DC motors and try working with those because those are pretty cheap and they don't require nearly as much energy. Or if I want to get dangerous and get expensive, I can buy a LiPo battery and try plugging that in here. But that could explode, I kind of don't want that.
Preferably LiPo battery. It's cool. More power, more juice.
I don't want exploding in my face.
Anyway, moving on. So we have access to this. So old school or high school, we have access to we have access to 3D printers in the engineering room. Yeah, multiple 3D printers actually, and not even only the typical additive ones we use the filaments, but the resin 3D printers. And since our first experience with the resin 3D printers, well, not the first experience with the 3D printers, the filament types, were not that good.
Yeah, nothing just worked.
Yeah.
Like, it would start printing, but then the printing would become off, and it like start printing to another side.
Well, that was the second printer.
And everything would pop off the bottom and start following the third.
The first printer was the makeup board, and it only accepts SD cards, and we don't have that. So anyway, the resin 3D printers we did much better. It was the Formlabs S2 Plus, I think.
Yeah, but
and
it works. The actual thing comes out nicer, but it takes so long to make anything.
yes, and the resin is poisonous.
Yeah.
And smelly. And, yeah, all
That's a haggle, but
yeah, it's only except. But the resolution is not high though.
yeah, the quality of it is surprisingly really good.
But it's always trade off between speed and quality. So I'll put up some pictures of what the initial spokes are that I'm planning to fit into the wheel, and those are what it looks like. Other attempts, so I found on GrabCAD like the model of the Curiosity wheel, and those are where I took the spokes from. I deleted everything else except for the spokes, resized it, make it really small, and then just had. So I'm planning to have 6 spokes going around, similar to how the Curiosity would be arranged, and then some type of central wheel assembly. I'm not very sure. I'm planning to 3D print it, but the 3D print didn't come out so well.
I think revised the file because something might have gotten corrupted in it, and then replan 3D printing because I got the printer to work. Did I put it on here? No. This to work on the 3D printer.
That's nice.
It's a fidget spinner. I don't have a bearing for it, but it actually came out working fine.
Yes.
So I just gotta do that.
Yeah, it's probably the fault.
That stuff.
I agree.
I think we just can't do it right.
Yeah, but I still don't know how to figure out the fine tunings of like the joke of everything and like how like that's the nozzle actually moves back and forth. Because if it's too fast then it just like whip phones around. Like
I can adjust all that. We just need to have trial and error.
Yeah.
One day.
And we're too lazy for that. Well,
You're too lazy for that.
Resin,
I got this to work out just fine.
The Formlabs software is much more intuitive. So
this is like 3 times the size of yours. It took 30 minutes. Yours took 7 hours.
Okay, moving on. What else? And back to the wheel center assembly. Lately, I've seen so you know the tape dispensers, the plastic tape dispensers that cost like $2 or like 50 cents probably. You know the inside there's like a plastic bit there, circle.
Yeah.
It's actually the perfect size to fit in here because it's about 3.5 centimeters, and so and it's made of plastic. It's pretty light. It's pretty strong. So if I want to try those and put it here. Because if I can attach the spokes to the piece, and then attach it to the wheel, then it could be spinning.
Yeah, because these motors here, just take one off really quick. They have this like nice little indent right here, so that way when a part attaches, they can twist it. With the DC motors, it's like a solid rod, so we have to find a way that I can like squeeze into it and hold it if I decide to go that route, which I probably will. Okay. These things are nice, but they just need so much electricity and I don't have that amount.
Yes. Is it? Yeah. I have a dog anyway. Well, there's more to it, but our dog has ended.
Yeah, the frame of the body, it's not here right now, it's currently drying, we just glued it together.
We glued the top half for the bottom frame of the thing and then the top frame. Because we actually didn't end up using clamps here, though we bought a bunch of clamps.
Yeah, they didn't work like we planned.
Yeah, because we can't. Oh, the supporting weight, so we have these 2 rods here. We should have bought like that thing. But these rods that we are putting the pressure on, and so this needs to be oriented on top of the actual bottom frames. And so we can't find a way to feasibly clamp it together. So we just let it just put some pressure on it, and then it currently drying right now. 24 hours to cure. Alright. Are you gonna talk about more of what we've done?
I mean, I can. It's kind of a big mess right now if we just took it all apart. So if you can imagine, these servos are going to be in the front and back. And what they're going to do is that they're going to turn the actual wheel side to side, giving it turning ability so it can turn it in place. These motors, or whichever motors I'm going to be using, are the ones that are actually going to turn the wheel. There's going to be 3 on each side for 6 total wheels. And so I could tell this to like move forward a meter, and it will move these in a rotation with however big he's going to make these. He's going to make like a bunch more of these.
It's going to be a bit larger and probably more iteration.
And it will give me the distance I want. I'm waiting on more parts. It's going to be a Bluetooth module, so that way I can take my computer, connect it via Bluetooth, and I can give it commands using the serial monitor, and that will allow me to communicate with it from a distance, so I can be running it without being connected by a computer, which is why I have this power bank here, so it can have its own power. And so right now I have it so the servos do turn in the direction I want them to. I just need to get the motors to run with the power I have. That's the biggest issue. And then just waiting on more parts from Amazon.
Suppose I'm also waiting on the 2 stock screws that I think to put it. Though I'm still not sure if it even is needed. So we'll see.
Oh well.
We'll see if it actually comes in.
I'm kind of upset that I have to replace those motors because it took me so long to solder them all together. And it probably wasn't good for me because this is my entire soldering station. And so pretty much the whole time I'm doing it, my face is right in the work. I don't really have a good fan. So I'll probably have lead poisoning, but I'll be fine.
Why don't you use lead free solder?
I don't know how much lead it actually contains. It says ROHS, which is reduction of hazardous substances. So it's either going to be like 99% tin, 1% lead, or 90% tin and then 1% like silver and other things. It doesn't actually say which one it is, so it could contain lead and it could not contain lead. I'm not really sure. But it smells bad.
Nice. So that's about it for focus right now. About the future, so 2 weeks later. So the frame should be glued together pretty much all of it.
Yeah, and the differential should be pretty much done.
Yeah, we had to use so for the frame we used Gould glue. There's normal gel clear. Have Gould glue because it's thin enough and it's strong enough.
Yeah.
But for the differential valve, I had to buy an extra epoxy.
Yeah, because I made you buy it. Because you won't buy anything else.
Yeah. Well, we almost got into an argument over it, but I was magnanimous enough to accept it. And then,
Yeah, because you should.
yeah. Right, so the epoxy is thicker, so it actually is able to hold. How do you explain it?
So the epoxy is, yeah, like you said, it is thicker because the 2 pieces of aluminum aren't 2D. They have depth to them. So as they stick together at an angle like this, there's going to be parts that are coming off. And it's impossible to drill through that because I'm drilling right through the center between both pieces. So to smooth it out, I'm going to be using the thick epoxy, which is going to like create a lump in that area, which is going to be like pretty much smooth surface I can drill through. And so once you put that onto an axle, then it would hold a lot better and it will like run smoother without wobbling to the sides.
Okay.
Because
I guess you can imagine, but I'm
So-
not like very sure.
So if you take one hand, put your other hand on it, your hands are smooth together, like
Okay.
one's above the other one.
Yes.
And so with the epoxy, what it will do is it will smooth this area out.
Yes. What about the Gould glue? It's runny, so it would like fit into better, wouldn't it?
No, because it's really flat. It's runny, and so it's not going to become thick. The
Okay.
epoxy is a lot thicker, so it can move upwards more, creating with.
I'm confused.
Okay,
Okay, yes.
do what I'm doing.
Yes,
Put your hands
yeah.
like this.
Well, I'm confused.
Put your hands like this.
Okay.
I'll explain it.
Yes.
See how there's a gap right there?
Yes, I will.
So if I try drilling right through that gap, it's
Yeah.
not going to work.
You're drawing where the connection is, but this
Yeah.
one. Okay.
But if I take the epoxy and I cover it over it, it's going to smooth out
Oh,
that
okay.
gap.
Yeah, I don't know. I thought you were talking about the interface between these things.
No, no, they will hold no matter
Yeah,
what.
Okay. There we go. Just explain. So that's the reason why we need a thicker glue, the bond, which is the epoxy. It's about $5.
I told you to buy like different one.
What
What?
do you mean? JB Weld is even more expensive. So.
It's like $1 for like an ounce of it.
Oh.
And we don't need
What?
that. Yeah, it's really cheap.
How many ounces is that? Just like
I don't know.
1.8 or something. I don't remember. But-
So it's not my fault.
Okay, so we're going in the future. We have the frame done. All glue together. Are you gonna like, finalize these camera? Are you gonna get it working?
The camera will wait until last because my main focus is going to be moving this rover. That's the toughest challenge right
Then
now.
how to do like all the wheels and
So I'm going to get some DC motors and I'm going to try those out and see how they do. Because if those ones can work better, then I'm going to use those. Which sucks because these motors were expensive.
it's fine. It's not feel painful. So. By 2 weeks later, hopefully I'll have 2 of the fine wheels done. I have them all measured out, so I just need to start folding measuring, folding it up, and then gluing the straws together. So both the wheels, the final wheels, hopefully will be done, so we can attach it and see. And about the resin printing, it's very finicky, the resin print, because it's always try and error. I have no experience printing it beforehand. So hopefully I'll have the 6 spokes, at least 6 spokes, hopefully 12, but at least 6 spokes assembled and see how it fits together. And probably some centerpiece that will glue
Yeah,
to.
if you can get one wheel,
Yeah.
and then we can just figure out how to attach to a motor from there, and then see how that works.
Okay. I was thinking about this. Well, this is not the final size, but this could be the trial wheel.
Well, get a final size,
Okay.
because I want to get the actual size. So when I program it, I can tell how far it's gonna go with each rotation.
Yeah. Any more remarks? Closing remarks?
Give us money. We're broke. We're gonna get demonetized.
It's okay, can we take it down? Is it okay for you?